In this lecture, we will discuss Chapter 4, Section 2, which is about displaying and summarizing quantitative variables. We will talk about how to summarize data for a single quantitative variable using shape, center, and spread. We will talk about displaying data using stem plots and histograms. And we'll talk about finding and using the 5-number summary to summarize a variable, as well as how to find outliers and construct box plots. To give you a sense of where we are, among the 4 stages of statistics, what we'll be talking about today falls under displaying and summarizing a single quantitative variable. Let's start with an example. This example comes from the student survey data, which you can download from Moodle. STAT students' earnings from the previous year in thousands of dollars begin with 12, 3, 7, 1, etc. And remember, this survey was conducted anonymously. What population did this data represent? Were these responses unbiased, do you think? Well, assuming that the sample is representative, the population would be students at the given university. I would suspect that the responses would be unbiased because it's anonymous. If it were not anonymous, people might be embarrassed to respond truthfully if they had an unusually high or unusually low income. So with this data set, what would be a good way to summarize it? One way would be to look at the mean. The mean, or average, was $3,776. Remember, if you look at just the numbers, those were in thousands of dollars. So if you found the mean of the numbers that were given in the data set, it would be 3.776. So can we conclude that the average for the population, that is all of the students at this university, was less than $5,000? We're going to focus on several different summaries. Mean will be one of them. We've seen that already. It's $3,776. But we're not yet going to be able to draw conclusions about populations. Remember, that's a question for inference, and we'll talk about that soon. So let's consider some definitions. The distribution of a quantitative variable talks about what all of the possible values of the variable are and how often they occur. Distribution can be summarized using 3 things: shape, center, and spread. Shape tells you which values tend to be more or less common. The center is a measure of what the middle of the distribution is. In other words, what response is most typical. And spread is a measure of how far the typical data point varies from the center. We'll dive deep into all 3 of these concepts as we move through this section and the sections to come. Let's start by considering the shape. Let's look at some terms associated with shape. A symmetric distribution is a shape that is balanced on either side of the center. There are roughly as many high values as there are low values. A skewed distribution is the opposite. In a skewed distribution, there are more high values than low values, or vice versa. If there are more low values than high values, we'll say that the distribution is skewed left. If there are more high values than low values, we'll say the distribution is skewed right. An outlier is a value that is far away from all the rest, unusually high or unusually low. We'll say a distribution is unimodal if it has only one peak, and bimodal if it has 2 peaks. We'll talk about how to find those soon. A distribution is uniform if all values are equally common. In other words, it's hard to identify any peaks, anything that occurs most commonly. A normal distribution is a very particular type of distribution that has a bell-shaped curve. Let's look at some visual examples of distributions. In this and the examples to follow, we'll be looking at something that is related to a histogram, which we'll be studying a little bit more later. This will be a graphical display of the values of a quantitative variable. We will put these graphs on a set of axes, like you might be used to, an x-axis and a y-axis. On the horizontal or x-axis, we'll have values of the variable. And then on the vertical axis, we'll see the frequency at which those values occur. So if the graph is high at a certain point, that means those values occur often. If the graph is low, close to the axis, that means that those corresponding values of the variable occur less often. So when we're talking about skew, we're talking about a distribution that has either an unusually high number of small values or an unusually high number of large values. The distribution would look something like this. If there are an unusually number of low values, because remember, low values are to the left and high values are to the right. This would be an example of a distribution that is left skewed. If you consider the mirror image of this, we would consider this to be right skewed because of the unusually high number of high values. This part of the distribution is sometimes called the tail. There's another tail over here on the left side for the left skewed distribution. You can identify whether a variable is skewed to the left or skewed to the right by looking at its shape, its histogram, and identifying where the tail is located. Now let's talk about the difference between bimodal and unimodal. A bimodal distribution has two peaks, so its distribution might look like this. If you've seen some of these statistical terms before, you may recall that the mode of a data set is the value that occurs the most often. Remember, the height of the graph here indicates the frequency at which the corresponding values appear. So two peaks means two values that occur more frequently than others. On the other hand, a unimodal distribution will have just a single peak. Two more shapes to talk about. A uniform distribution is one that has no peaks, no tails. It's just roughly a horizontal line. In a uniform distribution, every value occurs approximately with the same frequency. The last shape we'll talk about, and this one will be the most important to us going forward, is the normal distribution. A normal distribution has a very particularly defined mathematical shape. For us, roughly, it will look like a unimodal distribution, one peak, that's symmetric, which means that it is not skewed to the left or skewed to the right. The tails on the left side and the right side are approximately the same. We'll use three techniques to display values for a quantitative variable. Displays help us identify the shape of the distribution. We've already taken a peek at some of those, but now we'll dive a little bit deeper in how to actually create them for values of a variable that we're given. The first method is a stem plot. The advantage to a stem plot is that it gives the most detail. In particular, a stem plot actually displays all of the values for the variable. But since it gives so much detail about each individual data point, it comes with a disadvantage. For a large data set, we cannot use them. The second method is a histogram, which is most like what we saw on the previous slides. Histograms look a whole lot like bar charts, and we'll talk about how to create them soon. The advantage of a histogram is that it'll work for any size data set. But the disadvantage is that we lose some of the detail that we would have had with a stem plot. Finally, we'll look at a box plot, which is sometimes also called a box and whisker plot. A box plot has the advantage of showing outliers and makes comparisons for relationship between a categorical and a quantitative variable identifiable visually. We can look and see what the relationship is. But the disadvantage is that we lose even more detail than we did with a histogram. Let's start by considering the stem plot. A stem plot is a visualization that consists of a vertical list of stems, those are going to be numbers, each followed by a horizontal list of leaves, also consisting of one digit. These are also numbers. So the stems are listed vertically, and next to each stem, the leaves are expressed horizontally. One set of leaves for each stem. So let's look at an example. Here's a list of the masses in thousands of kilograms of 20 dinosaur species. Let's create a stem plot and ask what it tells us about the shape of the distribution. We'll use the first digit of each of the data values to create the stems. Notice that the smallest first digit is 0 and the largest first digit is 5. So we'll start with 6 stems consisting of the numbers from 0 to 5 inclusive. Now that we have our stems, let's add the leaves, which will come from the next digit. Starting with the 0 stem, the second digits are 0, 0, 1, 2, 4, 6, 7, and 7. So we will list each of those horizontally next to the 0 leaf. The 0 stem. Let's move to the next stem, which is 1. We'll add 1 leaf for each data point. Notice that some get repeated because they occur more than once. And it's important, if you wish to use the stem plot to analyze the shape, that you keep these leaves lined up, one on top of the other, all the way down. Let's move on to the next stem, 2. There's only 1 point. And for 3. Now, notice that there are no data points that start with a 4. But it's important to keep the 4 stem in our stem plot. The reason why is that it shows us that there's a gap in the data. That the points associated with 5, that's the next stem, really are far away from the other data points. So how do we analyze this stem plot now that we have it? To identify whether it is skewed, start by rotating it so that the stems are horizontal, with the lowest numbers to the left. Then draw in a curve that hugs the top values along each stem. So follow along with the top leaves. And now look and see if there's a tail. There's a tail to the right, so this data set is right skewed. Rawr, there's a dinosaur. Notice his tail is to the right. He's right skewed. We also notice by looking at our curve that there is one peak, so we would call this distribution unimodal. Most of the data points are below 2,000 kilograms, and there are a few that are far away from the rest. Those would be outliers. Stem plots don't always work out exactly the way that we want them to. For example, we might have too few stems. If we have too few stems, we split them up so that each first digit becomes possibly 2 stems. When this happens, if the leaves are between 0 and 4 inclusive, they go in the first stem. If they're between 5 and 9 inclusive, they go in the second stem. Maybe that's still too few. In that case, we split them into 5. The first stem gets 0 and 1, the second stem gets 2 and 3, and so forth, and so forth. If that's still too few, we could split it into 10 stems, so that each set of leaves is only a single digit. If there are too many stems, we cut off the last digit or the last digits. Let's look at an example. This example takes data from the student survey data. Of those that are listed as other, we look at the total number of credits taken. Here they are. What shape would you guess for these non-traditional students? And how would we construct a stem plot to make this shape clear? Well, I would expect the shape to be left skewed because some of these others would be part-time students, and so they haven't taken many classes. To create the stem plot, one thing that we have to do to modify this first is to notice that we would use the tens digit for the stems, but since these first 2 data points don't have a tens digit, we'll pretend that there's a 0 right here in front of those. So that would give us 2 stems, a 0 and a 1. That doesn't give us a really good idea of the shape of the distribution because, well, there are only 2 sets of leaves. So we'll split these into 2. The first split for the first stem, which corresponds to the 0, remember that gets the second digits 0 through 5, since 4 is between, I'm sorry, not 0 through 5, 0 through 4, inclusive. So since the 4 falls into that first group, it'll go on the first stem. The 7 falls in the second group, which is the 5 through 9 group. It'll go on the second stem. The 1s will split into 2. 0 through 4 goes on the first stem. 5 through 9 goes on the second stem. As we expected, we do see skewedness to the left. Let's look at another example that requires us to truncate some digits in order to create our stem plot. Here, the data that we're looking at is the number of minutes each respondent spent on the computer the day before filling out the survey. Here's our data set, and the question is, how will we construct a stem plot to make the shape of the distribution clear? Well, if we try to make the stem be at the tens digit, since the tens go from 0 in this first one to, well, that's really 42 tens here in this last one. That's far too many stems for us to use. So what we'll do instead is cut off the last digit. We'll use the 100s as our stems and the tens digit as the leaves. So let's go through and strike out all of the ones digits, and let's plot what's left. Now, of course, we're losing a little bit of information. This is going to make 60 and 67 look the same, but that's okay. we're still going to get a good sense of what the shape of the distribution is going to look like. So now for the zeros, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 leaves. For the ones, we have 2 leaves. For the 2s, we have 2 leaves. For the 3s, we have 1 leaf. And for the 4s, we have 1 leaf. So now we can tell what the shape of our distribution is. The peak is way over to the left, and we have a long right-handed tail. So this is skewed to the right. All right, it's time to go back and now look at the second method of displaying a quantitative variable, the histogram. In order to create a histogram, what we do is we take our quantitative variable and we turn it into a categorical variable and then create a bar chart. So to create that categorical variable, what we first do is take the range of values that our variable takes, divide it up into intervals of equal length or equal width, figure out what the count is in each, and if we need to convert that to a percent or proportion, we do, and then use that to compute the vertical distance, the vertical height of each bar. Let's look at an example. Here we see the prices of 12 used pianos going from $100 to $2,300. And we want to construct a histogram. So the first thing we need to do is to divide the range of values into intervals of equal width. Since we're going from a really small number, relatively speaking, in $100 up to $2,300, let's try maybe intervals of width 500. So go from 0 to 500, 500 to 1,000, and so forth. So between 0 and 500, we've got a decision to make. Here's the histogram that I've created, and if you look right here, you see that I've indicated there are 2 pianos with price between 0 and 500. If you look at our actual data set, you'll see that maybe it looks like there are 3. I've made a decision here that the high number in each interval is not included, whereas the low number in each, the low endpoint of each interval is included. So when I say from 0 to 500, I mean I'm including the 0, not including the 500. Since I'm not including the 500 in that interval, the 500 gets included in the 500 to 1,000 interval, which is why we have 3 data points in that interval. So that's a decision that you get to make, which endpoint gets included and which endpoint gets excluded. But whatever you do, you need to be consistent. If you include the left endpoint in the first interval, you should include the left endpoint in all of your others. It's not unusual when you're creating a histogram, instead of plotting the or noting the endpoints of the interval, as I'm indicating with the arrows here, instead we indicate the midpoint of each interval. Again, that's a matter of personal preference and taste. Let's look at how to create a histogram using Excel. Creating histograms in Excel is not as easy as it should be. There are a few steps involved, so let's get started. Let's say we want to create a histogram of, again, I'm using the student survey data that you can get from Moodle. And let's take a look at the respondents' math SAT scores. It's in the column math. As before, I'm going to copy this data. I'm taking the whole column, and I'm going to create a new sheet so that I can isolate the data and work with it more easily. Under paste options, just pick the first one if that's given to you. Now remember, the first step in creating a histogram is to divide the range of values into equally spaced segments. In order to do that, I need to know what the biggest value and the smallest value we have are. But if you scroll down, I mean, there are so many of these data points. So how do we see them all in order? Well, if we select our entire column and then go to the Data tab at the top, there's an option for Sort. I'm going to click on Sort, and then it's going to ask me to sort by math because it sees math here in the top part of the screen, and the top of the column, because the checkbox here for My Data Has Headers is selected. It's going to sort on the values smallest to largest, and I click OK, and now everything is resorted, and I see the smallest value that we got is a 400. If I scroll all the way to the bottom, I see the biggest value we got, if we take out all the blanks, is 800. So it looks like we're running from 400 to 800. What I'm going to do next is create a new column. I'm going to label it bins. I'm using the word bins because many statisticians use the word bins to describe each of the intervals that we break the range up into. So our bins need to go from 400 to 800. I think if we go by 100s, that's only going to create 4 bins, and I think maybe we want more than that. So let's divide that up into 8 bins. Each will have width 50. So my first bin interval will be at 400. The next one will be at 450. And now, instead of typing all these in, I'm going to show you a shortcut. Since each bin number is going to be 50 more than the one above it, I'm going to do the rest of this using a formula. The way you type a formula into Excel is to start by typing the equal sign. Equals tells Excel that what it's about to see is a formula. And what I want to do is say that what's going to go in this cell is going to be equal to the number in the cell above it. I'm just clicking in the cell above it to select it. So now it says B3. Notice that's the cell above. Plus 50. And when I push enter, sure enough, it adds 50 to the previous one. The nice thing about this is if you select the cell that has our formula in it, you notice that the bottom right corner right there, there's a little box, and as I move the cursor near it, the cursor turns into a plus. That means it's ready to take that formula and copy and paste it somewhere else. So what I'm going to do is I'm going to click in that corner and I'm going to drag down. And what it's going to do is it's going to take and copy that formula and paste it into all these other cells and populate the rest of those automatically. Now we're ready to create our histogram. The histogram tool is located in the Data Analysis menu. You'll find that under Data. But if you look at my menu here at the top, I don't see Data Analysis anywhere. The reason for that is, by default, Data Analysis is turned off. Let me show you how to turn it on. Go to your File menu and select Options. Under Options, you should see a sub-menu called Add-ins. I'm going to select Add-ins and then go at the bottom where it says Manage. I want to manage the Excel add-ins and I'm going to click Go. What we want is in the Analysis Tool Pack. So let's click the box next to Analysis Tool Pack and click OK. And as if by magic, under Data, you now see Data Analysis. There are lots of things that we're going to use in this Data Analysis menu in the future. So if it's not already installed in your Excel, now's the time to do it. So let's click on Data Analysis. And my computer's thinking more than it ought to. Oh, not responding. That's good. There we go. What I'm looking for is histogram. So scroll down until you see histogram if you need to, and click OK. Now for the histogram, we need an input range. I'm going to click the box here on the end, and I'm just going to click the label here for column A up at the very top. That's going to select the whole thing. It wants a bin range, so I'm going to select my bins, including the word bins, because I'm using labels for my data. I'm going to check the box next to labels, because again, I'm using labels for my data. I want to put this on the same ply, the same worksheet. So instead of new worksheet ply, I'm going to click the button next to output range. And what I'm going to do is just pick a cell somewhere over to the side, in column D maybe. And now I also want a chart. So I'm going to check the box next to chart output, and I'm going to click OK. What I get is the conversion from our numerical data into categorical data reported with a frequency. And here's our histogram. Now, this isn't very big, so I'm going to click on the inside the chart here, and you should get some handles that allow you to make this nice and big. Let's make it wider too. Maybe not quite that wide. So one thing to notice is that this tool automatically creates a more category. We don't have anything more than 800, so since I don't need that, I'm going to select it and I'm going to delete it. And more just disappeared from our histogram. There's still a space for it there though, so I'm going to right click on those two cells that I selected and click delete. Is that going to make the whole thing go away? Until it shifts cells up. There we go. Now it's gone. The other thing to notice is that since I started at 400, notice that it came up with a frequency of 2. And if you look at our data, there are actually 2 data points that are equal to 400. That means that the histogram in Excel automatically includes those endpoints in the lower side. So the 350 to 400 bin includes 400. The 400 to 450 bin includes 450, but not 400. Now this doesn't look very much like the histograms we've seen before because the bars are spread out, and you notice the labels aren't great either. The 550 here, that should be the right-hand endpoint. That should maybe be over here somewhere. So let's see if we can fix that some. I'm going to click in the chart here. I have clicked on one of the bars, you'll see, and you see the little handles around that bar. I'm going to right click and I'm going to go down to Format Data Point. I'm going to scroll over so I can see the whole thing here. And now you see here series overlap and gap width. Right now the gap between bars is 150% of the width of the bars. I want to make that a whole lot smaller. Don't make it all the way to 0 or you won't be able to see any distance between them at all. But there, that looks a whole lot better. So now I want to try to get the labels over in the right place. So I'm going to click inside my chart down here on one of the labels. And you see alignment as an option. Vertical alignment is currently middle centered. The text direction is horizontal. I can change it to rotated so that it's vertical if I wanted to. And now I'm clicking back over here on the axis on the little bar here. I'm going to go down to tick marks. The tick marks are right. It's the labels that I want. No, that's right too. The number, that's right too. So how do I move this over? Go to Format Axis. Well, I'm not really sure how to get those labels moved over. If you click on the labels, you can do things like change the angle, and you can make it rotated so that it's vertical if you want. And I can align it vertically, but I can't figure out how to get those moved over. So hopefully that's not a big deal for you. It's not going to be for me, but I think this histogram looks a whole lot better. So now the question is, what's the shape? It looks like it's maybe skewed a little bit to the left. There seems to be more of a tail on this side than there is on this side, but there's not much of one. This is pretty close to normal, actually. So that's how to create a histogram using Excel. All right, so we've seen shape. Now it's time to look at measuring the center and the spread. First, the median of a set of data for a quantitative variable is a measure of the center. It gives you a sense of where the middle of the data are. We've already seen using the mean to measure the center. The median is a different way to measure the center. The median is the middle number if you have an odd number of values. If you have an even number of values, the median is the average of the two that fall right in the middle. So if you have 20 data values, the two in the middle are the 10th and the 11th. So take the 10th and the 11th and find the average. Quartiles give you a sense of how spread out the data are, whether the data points are all clustered very tightly around the median or spread out. The first quartile is the number at which 1/4 of the data values are equal to that number or below that number. The third quartile is the point at which 3/4 of the data are equal to that number or below that number. You can think of the first quartile as being the median of the smaller half, and the third quartile as being the median of the larger half. If you're doing this by hand and you have an odd number of values, drop the median before you find the quartiles. Quartiles are a special example of percentiles. The percentile is the value at or below which a given percentage of the distribution's values fall. So the 10th percentile is the value at which 10% of the data are equal to or below that number. The 70th percentile is the number at which 70% of the data are at or below that number. That means that the first quartile is the 25th percentile because 25% of the data are at or below that number. The third quartile is the 75th percentile. We also want to define the range, which is the difference between the maximum and the minimum values. So if you're trying to find the range, find the smallest number that you've got in your data, find the biggest number you've got in your data, and subtract. Finally, the interquartile range is the spread of the middle half of the data values. In other words, it's the 75th percentile, or the third quartile, minus the 25th percentile, or the first quartile. We'll abbreviate that using the letters IQR. So if we want to summarize a quantitative variable in a way that indicates both its center and its spread, one way to do that is with the 5-number summary, which includes the minimum value, the first quartile, the median, the third quartile, and the maximum value. A second method for summarizing a quantitative variable indicating both center and spread is to use the mean and the standard deviation. For us, those are going to be more useful, but overall tougher to find. We'll save those for the next section. Let's look at an example. Of the 14 non-traditional students in the student survey data, here are the credits taken so far. Let's find the 5-number summary, the range, and the IQR, the interquartile range. The first number in the 5-number summary is the minimum value, which, since this list is ordered already, I know that it's 4. The highest value on the list is 18, so that's going to be the maximum. But let's go next to the second number in the 5-number summary, which is the first quartile. To find the first quartile, remember that's the median of the lower half of the data. So I've put a line here halfway in between. So I've got 7 values above, 7 values below. The number right in the middle of those 7 is 11. So 11 is our first quartile. Since I've got an even number of data points, the median is the average of the 2 in the middle. Those are 13 and 14. The average is 13.5. Now looking at the top half, the number that appears right in the middle is 17. And our maximum value again is 18. The range is the difference between the maximum and the minimum value. 18 minus 4 is 14. And the IQR is the third quartile minus the first quartile. That gives us an IQR of 6. Remember that we defined outliers as points in our data that are unusually high or unusually low. That can be a matter of opinion. So for this book, for our class, we will always define outliers in the following way. We will use the 1.5 times IQR rule. To apply this, the first thing to do is to compute the IQR, multiply it by 1.5, and subtract that number from Q1. In other words, we're finding a number that is 1.5 times the IQR below Q1. Any data points lower than that number would be considered an outlier on the low side. Similarly, if you go to Q3 and add 1.5 times the IQR, we'll call that a high outlier if it's a point beyond or above that number. Remember, the IQR is the interquartile range. It's all the data values between Q1 and Q3. To figure out if we have any outliers, go to Q1, subtract 1.5 times the interquartile range, and look and see if you have any data points farther to the left. If you do, they're low outliers. Then go to Q3, add 1.5 times the interquartile range, and see if you have any data points above that. If you do, those are high outliers. The last way that we will display a quantitative variable is using a box plot. A box plot is a visual representation of our data that shows the median, the quartiles, and the extreme values, the maximum and minimum, with special treatment for outliers. The bottom whisker will go to the smallest non-outlier in our data set. The bottom of the box will be at Q1. There'll be a line through the box at the median. Top of the box will go to Q3, and from Q3 we'll extend a whisker out the top to the maximum non-outlier. If we have outliers, we'll use stars to show where they occur. Let's look more closely at identifying outliers. Let's say that we were still looking at the credits taken by our non-traditional students. Remember, the 5-number summary was 4, 11, 13.5, 17, 18. That's the minimum, Q1, median, Q3, and the maximum. Did we have any outliers? Well, the first thing to do is to compute the interquartile range. To do that, we need to identify Q1 and Q3, which we have. We subtract them to get 6. So our interquartile range is 6. Next, we multiply the interquartile range by 1.5, which gives us 9. So we want to go 9 above 17, that's Q3. We want to go 9 below 11, which is Q1. That gives us a 2 on the low side. Since 2, there are no data values below 2, remember 4 was the minimum, we have no low outliers. If we add 9 to 17 to go up to the top, that gives us a high outlier would have to be at 26 or above, but our maximum was 18, so we have no high outliers. So let's make our box plot. Again, the same 5-number summary. To construct the box plot, we'll start by creating a vertical axis for the credits, and we'll notice where each of the numbers in the 5-number summary are located. Then we draw a box that goes from
Q1 to Q3 with a line through it at the median, a whisker at the bottom that goes down to our minimum value as long as the minimum value is not an outlier, and another whisker that goes out the top to our tallest or highest value, the maximum value, as long as it's not an outlier. By looking at this, we can see that the most common values are the ones between Q1 and Q3. So typically we're looking at credits around the median, 13.5. And we can see that the distribution is skewed to the left because of the long whisker to the left or to the low side. To recap, we talked about how to display a quantitative variable using a stem plot and a histogram. We talked about identifying the shape of a distribution, whether it was symmetric or skewed, skewed to the left or skewed to the right, whether it was unimodal or bimodal, normal. We looked at measures of center and spread using the median and the range and the interquartile range. We talked about how to identify outliers and to display our data using a box plot.